In Alabama, Alabama Administrative Code 510, X 22.2.1 defines a qualified person as someone with the knowledge, training, experience, and skills necessary to work safely with electrical equipment. Licensed electricians are required to have a state-issued license and meet certain experience and training requirements according to Alabama Administrative Code 510, X 22.16. In Alaska, Alaska Administrative Code 11 AAC 52.110 defines a qualified person as someone who has received training in safety-related work practices and has demonstrated proficiency in the operation and maintenance of electrical equipment. Licensed electricians in Alaska are required to pass an examination and have a state-issued license. This is detailed in Alaska Administrative Code 11 AAC 52.200. In California, the California Electrical Safety Orders, or CISO, Section 229.1 defines a qualified person as someone with the requisite knowledge, training, experience, and skills to safely perform electrical work. Licensed electricians in California are required to have a state-issued license and meet certain experience and training requirements, as stated in Business and Professions Code Section 7015. In Alabama, Alaska, and California, qualified personnel are not necessarily licensed electricians. However, licensed electricians are considered qualified personnel, as they have met the necessary training and experience requirements. The requirement for qualified personnel to work above 50 volts under NFPA 70E and above 300 volts under NES generally applies to industrial and commercial settings. In residential settings, licensed electricians are typically required for work above a certain voltage threshold, such as 50 volts in Alabama and 60 volts in California. It is important to understand the specific requirements in each jurisdiction and set in to ensure compliance with electrical safety regulation. The term qualified personnel refers to individuals who have the necessary skills and knowledge to perform a specific task safely. This qualification is often demonstrated through training, experience, and certifications. It is crucial for ensuring safety in various industries, including electrical work. The definition of a qualified person can vary depending on the specific industry, regulations, and the nature of the work being performed. Generally, a qualified person has the ability to recognize and avoid hazards associated with their work. They understand the equipment and procedures involved and can competently perform their tasks. In the context of electrical work, a qualified person typically has received training in electrical safety, understands the relevant codes and standards, and is proficient in using electrical testing equipment. They also know how to de-energize circuits and implement lockout-tagout procedures to prevent accidental energization. Licensing is a process by which a governmental agency grants permission to an individual to engage in a particular profession or occupation. Licensing aims to protect the public by ensuring that practitioners meet certain minimum standards of competence and ethical conduct. The requirements for obtaining a license can vary depending on the profession and the jurisdiction. In many professions, licensing involves completing a specific educational program, passing an examination, and meeting certain experience requirements. Licensed professionals are typically subject to ongoing regulation and oversight, including continuing education requirements and disciplinary procedures for misconduct. Licensing can help to ensure that professionals are competent, ethical, and accountable to the public. The NFPA 70E, or the Standard for Electrical Safety in the Workplace, is a consensus standard developed by the National Fire Protection Association. It provides guidance on safe work practices for employees who work on or near energized electrical equipment. The NFPA 70E aims to reduce the risk of electrical shock, arc flash, and other electrical hazards in the workplace. It covers a wide range of topics, including electrical safety training, hazard assessment, personal protective equipment, and lockout-tagout procedures. The NFPA 70E is widely recognized and used in the United States and other countries as a benchmark for electrical safety in the workplace. Compliance with the NFPA 70E can help employers create a safer work environment and reduce the risk of electrical injuries and fatalities. The National Electrical Safety Code, or NESC, is a standard published by the Institute of Electrical and Electronics Engineers, or IEE, that provides guidelines for the safe installation, operation, and maintenance of electrical power and communication systems. The NESC covers a wide range of topics, including clearances, grounding, wiring methods, and equipment installation. The NESC is used by utilities, electrical contractors, and other organizations involved in the design, construction, and maintenance of electrical systems. Compliance with the NESC helps to ensure the safety and reliability of electrical infrastructure and reduces the risk of electrical hazards. The NESC is updated regularly to reflect changes in technology and industry best practices. Voltage is a measure of electrical potential difference between 2 points in a circuit. It is the driving force that causes electric current to flow. Voltage is measured in volts. A higher voltage indicates a greater potential difference and a greater ability to drive current. Voltage can be either alternating current or AC, or direct current or DC. Alternating current voltage varies periodically with time, while direct current voltage remains constant. Understanding voltage is essential for working with electrical circuits and equipment. Electrical safety standards often specify voltage thresholds for safe work practices. Current is the flow of electric charge through a circuit. It is measured in amps. Current is caused by the movement of electrons through a conductor. The amount of current flowing through a circuit depends on the voltage applied and the resistance of the circuit. High currents can cause overheating and damage to electrical equipment. Understanding current is essential for designing and troubleshooting electrical circuits. Electrical safety standards often specify current limits for safe work practices. Resistance is a measure of how much a material opposes the flow of electric current. It is measured in ohms. A higher resistance indicates a greater opposition to current flow. Resistance depends on the material, length, and cross-sectional area of the conductor. Resistors are components used in electrical circuits to control current flow and voltage levels. Understanding resistance is essential for designing and analyzing electrical circuits. Electrical safety standards often specify resistance values for grounding and bonding systems. In Alabama, the Alabama Administrative Code establishes the rules and regulations for electrical work. These regulations cover a wide range of topics, including licensing requirements, electrical safety standards, and inspection procedures. The Alabama Administrative Code is enforced by the Alabama Electrical Contractors Board. Compliance with the Alabama Administrative Code is essential for ensuring the safety and quality of electrical installations in the state. The Alabama Electrical Contractors Board is responsible for licensing and regulating electrical contractors in Alabama. The board also investigates complaints against electrical contractors and takes disciplinary action when necessary. The Alabama Electrical Contractors Board is committed to protecting the public by ensuring that electrical work is performed safely and competently. In Alaska, the Alaska Administrative Code establishes the rules and regulations for electrical work. These regulations cover a wide range of topics, including licensing requirements, electrical safety standards, and inspection procedures. The Alaska Administrative Code is enforced by the Alaska Department of Commerce, Community, and Economic Development. Compliance with the Alaska Administrative Code is essential for ensuring the safety and quality of electrical installations in the state. The Alaska Department of Commerce, Community, and Economic Development is responsible for licensing and regulating electrical contractors in Alaska. The department also investigates complaints against electrical contractors and takes disciplinary action when necessary. The Alaska Department of Commerce, Community, and Economic Development is committed to protecting the public by ensuring that electrical work is performed safely and competently. In California, the California Electrical Code, which is based on the National Electrical Code, and the California Electrical Safety Orders establish the rules and regulations for electrical work. These regulations cover a wide range of topics, including licensing requirements, electrical safety standards, and inspection procedures. The California Electrical Code and the California Electrical Safety Orders are enforced by the California Department of Industrial Relations. Compliance with the California Electrical Code and the California Electrical Safety Orders is essential for ensuring the safety and quality of electrical installations in the state. The California Department of Industrial Relations is responsible for licensing and regulating electrical contractors in California. The department also investigates complaints against electrical contractors and takes disciplinary action when necessary. The California Department of Industrial Relations is committed to protecting the public by ensuring that electrical work is performed safely and competently. Qualified personnel in electrical work must have a thorough understanding of electrical safety principles and practices. This includes knowledge of the hazards associated with electricity, such as electric shock, arc flash, and arc blast. Qualified personnel must also be trained in the proper use of personal protective equipment, such as insulated gloves, safety glasses, and arc-rated clothing. They should be able to identify and mitigate electrical hazards, such as exposed wires, damaged equipment, and overloaded circuits. Qualified personnel should also be familiar with lockout-tagout procedures to prevent accidental energization of equipment during maintenance or repair. Licensed electricians have demonstrated their competence in electrical work by completing a required apprenticeship program, passing an examination, and meeting other licensing requirements. Licensed electricians are expected to adhere to a code of ethics and to maintain their skills and knowledge through continuing education. Licensed electricians are typically required to obtain permits and inspections for electrical work to ensure compliance with built-in codes and safety standards. The relationship between qualified personnel and licensed electricians is that licensed electricians are considered qualified personnel by virtue of their training and experience. However, not all qualified personnel are licensed electricians. For example, an industrial maintenance technician may be qualified to perform certain electrical tasks within their facility, but they may not be licensed to perform electrical work for the general public. The specific requirements for qualified personnel and licensed electricians can vary depending on the jurisdiction and the type of work being performed. In general, it is important to ensure that anyone performing electrical work has the necessary skills, knowledge, and qualifications to do the job safely and competently. The NEC, or National Electrical Code, is a widely adopted standard for the safe installation of electrical wiring and equipment in the United States. It is developed and published by the National Fire Protection Association, or NFPA. The NEC provides detailed requirements for electrical installations in residential, commercial, and industrial buildings. It covers a wide range of topics, including wiring methods, overcurrent protection, grounding, and equipment installation. The NEC is updated every 3 years to reflect changes in technology and industry best practices. Compliance with the NEC is essential for ensuring the safety and reliability of electrical systems. Overcurrent protection is a critical safety feature in electrical systems that protects against excessive current flow, which can cause overheating, fires, and equipment damage. Overcurrent protection devices, such as circuit breakers and fuses, are designed to interrupt the flow of current when it exceeds a predetermined level. Circuit breakers are resettable devices that can be tripped manually or automatically when an overcurrent condition occurs. Fuses are one-time use devices that melt and break the circuit when an overcurrent condition occurs. Selection and installation of overcurrent protection devices must comply with the NEC and other applicable standards. Grounding is the process of connecting electrical equipment and systems to the earth to provide a low-impedance path for fault current. Grounding helps to protect against electric shock and equipment damage by providing a path for fault current to flow back to the source, causing the overcurrent protection device to trip and energize the circuit. Grounding systems must be properly designed and installed to ensure their effectiveness. The NEC provides detailed requirements for grounding electrical systems. Electrical safety training is essential for all personnel who work on or near electrical equipment. Training should cover the hazards associated with electricity, safe work practices, the proper use of personal protective equipment, and emergency procedures. Training should be conducted by qualified instructors and should be updated regularly to reflect changes in technology and regulations. Employers are responsible for providing electrical safety training to their employees and for ensuring that they are competent to perform their assigned tasks. Lockout-tagout is a safety procedure used to prevent accidental energization of equipment during maintenance or repair. The procedure involves disconnecting the equipment from its power source and then locking and tagging the disconnect switch to prevent it from being turned on accidentally. Lockout-tagout procedures must be followed whenever electrical equipment is being worked on to protect workers from electric shock and other hazards. Personal protective equipment, or PPE, is equipment worn by workers to protect them from hazards in the workplace. In electrical work, PPE includes insulated gloves, safety glasses, arc-rated clothing, and other specialized equipment. The type of PPE required depends on the specific hazards present in the work environment. Employers are responsible for providing PPE to their employees and for ensuring that they use it properly. Arc flash is a dangerous electrical explosion that can occur when there is a fault in an electrical circuit. Arc flashes can generate intense heat, pressure waves, and toxic gases, which can cause serious injuries or fatalities. Arc-rated clothing is designed to protect workers from the thermal effects of arc flashes. Arc flash hazard assessments are conducted to determine the potential arc flash hazards in a workplace and to select the appropriate PPE. Electrical safety audits are conducted to identify potential electrical hazards and to ensure compliance with safety regulations. Audits can be conducted by internal staff or by external consultants. The findings of the audit should be used to develop and implement corrective actions to improve electrical safety. Electrical safety programs are comprehensive plans that outline the policies, procedures, and practices used to manage electrical hazards in the workplace. The program should include elements such as training, hazard assessment, PPE, lockout-tagout, and emergency response. The program should be reviewed and updated regularly to ensure its effectiveness. Electrical safety culture is the shared values, beliefs, and attitudes of an organization regarding electrical safety. A strong safety culture is characterized by a commitment to safety at all levels of the organization, active participation by employees in safety initiatives, and a willingness to learn from mistakes. Creating a positive safety culture is essential for preventing electrical accidents and injuries. The hierarchy of controls is a system for prioritizing hazard control measures, with the most effective controls being implemented first. The hierarchy of controls includes elimination, substitution, engineering controls, administrative controls, and personal protective equipment. Elimination involves removing the hazard altogether, while substitution involves replacing a hazardous substance or process with a safer one. Engineering controls involve modifying equipment or the work environment to reduce the hazard. Administrative controls involve implementing policies and procedures to reduce the hazard. Personal protective equipment is the last line of defense and should be used in conjunction with other control measures. Electrical hazards in the workplace can be identified through a variety of methods, including visual inspections, electrical testing, and hazard assessments. Visual inspections can reveal obvious hazards such as exposed wires, damaged equipment, and overloaded circuits. Electrical testing can be used to identify hidden hazards such as insulation breakdown and ground faults. Hazard assessments involve a systematic evaluation of the workplace to identify potential electrical hazards and to determine the appropriate control measures. Electrical codes and standards are constantly evolving to reflect changes in technology and industry best practices. It is important for electrical professionals to stay up to date on the latest codes and standards to ensure that their work is safe and compliant. Continuing education courses, industry publications, and professional organizations can help electrical professionals stay informed about changes in the electrical industry.